Anything exciting happened today? Maddie, you look like you're tired. Why?
I don't know.
Because you were here yesterday.
Yeah.
That's why. How many hours were you here yesterday?
6.
Cutting hair the entire time?
No, we were doing perms.
Perms yesterday. I need a perm pretty
It's
soon.
not horrible. You don't want one.
I need one.
No, you don't.
I want to put a little balance and curl in my hair.
No, you do not want one. Unless you want to have egg smell in your hair for 2 days.
I hate the smell of perms. Oh, it's so nasty.
Oh, yeah.
Disgusting. All right. So the only thing you had to do the past couple days, look over your notes, and then I gave you a little bit of Khan Academy to try. Abby, are you okay?
What?
You look concerned about something.
I'm always concerned.
No, you look like really like something like you're worried. You keep looking at the board like there's some concern of what's on the board. Are you concerned with what's on the board?
I don't know.
Okay. Anyways, so the past couple days we had some, we did some stuff in here. You guys had some problems. We actually went over your problems already from the bookwork. And then yesterday you had a little Khan Academy assignment. Hopefully that was okay for you guys. It was just the basics of exponential, logarithmic, inverse function idea. So yeah, is there anything you want to ask before we kind of get going today? No? All right. So this, the blue is review. I want you to just rewrite that in a different form. That's all I want you to do. And you can do this in your notes for the day. That's fine, because we're going to move right into notes from this. Sha-na-na-na-na-na. All right. Pachow. Where's that at? Do. So that's the live stream on Zoom right now. See that? There it is. He's waiting. Oh, he's going in through the Zoom. Yeah. Doofus. I didn't hear a ding dong on my. He says it says there's 2 people in there. Oh, it didn't. For some reason, I didn't hear the tone. Okay. That's why YouTube Live's better. I don't have to worry about that. Check that out. I love this. Okay. What's going on here? I can pull that out of here. We don't need that. There's what you're working on right now. Woo! Yep. Oh, whoa. What is going on here? The first one, the blue one, should be child's play. The red one may take a little thought before you get to it, but should not take a lot, hopefully. Hopefully you can get to it. So yeah, all right. And today, I do not want to use the sword of knowledge, so I'm going to use the orange of fear.
Maybe that's what she's.
That means if I don't like an answer, I might throw this right at your head. Orange of fear.
That's not funny.
It is a little bit. I would never do anything that hurts you. Come on. All right. We are ready here to do this problem. So the first one on the left, all I want you to do is go from exponential to logarithmic form. So this should be log base of y equals x. I changed the variables on purpose just to see if I could confuse you, and it worked. Okay, it's log base 3 of this And the exponent's always on one side. Remember, a logarithm is another way of writing an exponent. Exponent, exponent, exponent. Okay? Now the red one, notice, this one is y equals 2 to the x minus 3. Before I can write this in logarithmic form, I have to get this by itself. You can't change it until that is by itself. So you have the base with its exponent isolated. So my first step here is I would need to add 3. So I get y plus 3 equals 2 to the x. And now I could write this in logarithmic form. It would be log base 2, and it's of this entire thing. So if I want of the entire quantity, I'm going to put it in parentheses. Equals x. Okay? Now, I want to talk about that. That's kind of why I did this. This one right here, okay? One of the things when we got this book, I don't know how many years ago it was, 8, 9 years ago, this book came to us. We started using it. They don't put this in parentheses. I have a problem with that. And the reason I have a problem with that is if I write this, if I wrote something like this, how do I know if that is this or is it this? Because they're not the same thing, are they? They're not. So when it's written like this, there's too much like left to interpretation. I don't like that. I like to put, if it's of the entire thing, I will put it in parentheses. The book, for some reason, doesn't. I hate it for that reason. I hate that part of it. It's better to put it in parentheses and know it's the logarithm of the entire quantity. Okay? Because those are two different things. Okay? And if you ever see a problem, I give you a problem and you want to know, is this supposed to be in parentheses or not? I'll tell you. I'll try to clarify that for you if there's one that you're trying to think about and you wonder about it. Okay. All right, great. Here we go. No calculator allowed. Give me an estimate of that. Woo! Estimate. Estimate. It's a guesstimate. Estimate, but it better be at least a good estimate. Okay. No calculatrice allowed. Orange of fear could come near. Give me the sign. Oh yeah, okay. You should be done if you know this. If you have an idea about this. So in your own words, I don't want you to rewrite this. I just want you to tell me in your own words, what am I asking you? What? Yeah, so like take this and say, Mr. Snyder's asking me of
what power of 8 would it equal 68?
Okay, so what power of 8 is 68? That's what it's asking me. We know 8 squared is, and so it's got to be what? Bigger than 2, right? Exponent 8 squared is 64. The exponent 2 gives me 64. I need an exponent bigger than that to give me 68. So if you said something like maybe, oh, I don't know, 2.08, you just guess that. I'd love that. If you gave me 2.3, I'd be fine with that. If you gave me something less than 2, what would happen?
The orange.
The orange. Bigger than 3? The orange. Okay? That just allows me to know that you really understand what it's saying. If you can give me an estimate, that's a good thing. Okay? Here, let's do another one. You ready? You love this stuff. I know you do. All right, you should be done. Between what two whole numbers is this going to fall? 3 and 4. Which should it be closer to? 3. 3 cubed is 27. 3 to the 4th is 81. That's a lot closer to 27 than 81. So maybe you would tell me it's about what? 3.1, and I'd be happy with that. So you're understanding what it's asking you. Okay, when you see this, immediately you should be saying, oh, what exponent of 3, what power of 3 gives me this? You need to think that when you see this. Okay. This is review 2. Kind of, right? We were solving things in here. Now this one, I'll tell you what, oh yeah, funny. He wants the angry orange. It'll change to angry orange pretty soon, man. Okay, let's do this. We're gonna do 2 problems here. I think I accidentally erased the other one after last period. There's supposed to be one over here. That's kind of like a review of what we did Monday, Tuesday. Okay, here we go. Here we go. Solve that. Exact. Exact. Don't give me a decimal. I want an exact. An exact means you're just going to leave it in a form that's not a decimal. Exact. Don't freak out. It's not as bad as you think. I think Sullivan was in here messing him up again. He's such a goober. If I want to solve a logarithmic equation, I should probably do what? Exponential. Yeah. Write it as an exponent. What would this be? X to the 3rd power equals 83. How do I solve this? Raise the left-hand side to what power? Thank you. So guess what X is? X equals 83 to the... Booyah! Done. That's an exact answer. I like that answer. I love it. Beautiful. All right. Do the blue one now. Do the blue one. Blue the do. Why are you looking at me that way, Rachel Mitter? Why are you looking at me that way? I need something to throw that won't hurt.
That won't hurt.
No, I'm not going to throw the trash can at you, Abby. Gosh, I'm not that mean. I need something that I can throw that will not hurt you when I hit you with it. Tennis ball, too hard. Tray, too hard. Big calculator, too hard. Aha! Bubble wrap. That is definitely not too hard.
Not too hard, but I like it.
You got about 30 seconds until I get this thing fixed. You got 15 seconds. Oh, you got 10 seconds. You're running out of seconds.
You become too evil.
Who wants to see what this feels like if they get it wrong? Anybody?
I just don't.
Tim wants to see what it feels like. He doesn't get it wrong. Does that hurt? No, of course not. It's air.
Imagine if
I'm throwing air at you.
Air.
That's it. It's air. Okay. Who wants to tell me the first step on this?
Well, you know that they each equal 8 because if they're the same thing,
Yeah. How'd you know that?
because it's like the same thing.
They're the same thing.
Yeah.
So wait, you're saying I have two of the same thing?
Yeah.
Oh, so you're saying that I really and truly what I have is I have 2 times. That's what you're telling me. Because if I mean they're like terms, I can just add them then, you're saying, basically. Because they're the same. Oh, how beautiful is that? So if I have 2 log base 2x's that equals 16, then, like you said, that would mean that 1 log base 2 of x has to equal 8. Because I could just do this, divide by 2, usually do. And then, of course, x equals what? X equals? Write it as an exponent. X equals, there's the base. Yeah. I did this. It's funny how everyone wants to say 3. Everyone thinks 2 to what power is 8. It's 2 to this power is x. Be careful. That's why we just want to be able to change forms. If you can change forms, you just go, oh, 2 to the 8 equals x. Boom, bam, slam, I'm done. I will not throw this. Okay. What? All right. Are we okay with that one? Those are like terms. How do I know they're like terms? Because these bases are the, and so are these values right here. If these were not the same, I couldn't add them. If the bases weren't the same, I could not add them. Wouldn't be allowed to. Wow. Okay. So what would I do in a case like this?
Good question.
That is the
Because these are not like terms. They're not alike. They have the same base. But this one's got an x, and this one's got an x plus 1. I don't know what I'm going to do here. You know why? Well, I do. You don't. You know why I don't know what to do yet? Or why you don't know what to do yet? Because you have not been given the tools to do that problem yet. So I need to give you the tools you need when you see problems like this. That's our goal today. How am I going to approach that problem in the future? What tools do I need? Well, what you need, no, you don't need Desmos. You need some properties of logarithms. You need some properties of logarithms in order to do that type of problem. So today, we're going to be talking about some properties. The first 3 I give you are important, and you'll be using those right away. The last one I give you today, I'm going to talk about it. It's not nearly as important as it used to be, understanding it and using it, but there will be times when you need it, and I will talk about that when we get to those types of problems. Okay. All right. Properties of logarithms. So this problem right here, if I came back to this problem, actually in about 2 minutes, we should be able to do this problem. I'm not coming back to it because I have a different one. All right, here we go. There are 3 properties we want to talk about. Product property, quotient property, and the power property. And these are all properties of logarithms. Okay? They're all properties of logarithms. So here we go. Product property for logarithms says the following. If you take two logarithms that have the same base, but they have different values here. So log base b of m and log base b of n. And I want to add them together. That's exactly what that previous problem was asking you to do. You are allowed to rewrite this as a single logarithm. And it would be log base b of the product of m and n. Notice we multiplied those. So the sum of these individual logarithms is equal to the logarithm of those products multiplying. Now what this is called, when I go from two logarithms down to one, we refer to that as condensing. We condensed. To condense means make smaller, make less. That's condense. Like chicken, like Campbell's soup that's condensed. They took it and they pulled the water out of it, and then you have to add the water in later, right? So this is like a can of chicken noodle soup, right here, before you make it. This is after you've made it, when you had to add the extra water into it, okay? So we call going from here to here condensing. If I go the other direction, that's, we said, to expand. Okay, that has been expanded. So to go from 2 down to 1 is condensing. To go from 1 to 2 would be expanding, in case you're asked to do that. All right. So that is going to allow us to do that previous problem when we see that type in the future. All right. I like it. That's good. Now, so here, let's see. Product, we're adding to, multiply. Notice that these are what kind of operations? Product property and quotient property. They're inverse operations. Now, I want you to think something. I want everyone to listen to me. These are inverse operations. And guess what? This statement's going to be an inverse operation to each other. And these are going to be inverse operations to each other as well. It's the opposite. So what that means is, hey, if I had not the sum, I would have to have the what? Difference of two logarithms in the same base. If I have the difference of two logarithms with the same base, I can rewrite it as not the product, but the, and that means I'm going to do what with them? Division. It's going to be log base b of m divided by n. So if you know the product property, the quotient property is just the inverse of it. When you think about it, inverses, inverse operations, those are inverses of each other. Okay. And again, condense, expand. Yes.
And the quotient property is always going to be the first logarithm.
Yes, it's always the first divided by the second one. Correct. Correct, correct, correct. Okay. And there's a, this here will kind of actually, we could explain why that's true using this last property on here as well. We might in a second. Who knows? All right. The last one is called the power property. Okay. So what the power property is talking about, it says, hey, what happens when I have some number being multiplied by some logarithm? So it's n times log base b of n. Okay. Now, to kind of understand how this works, this problem, this last one, I'm going to just do an example. I'm going to let n equal 3 on this problem. Is that okay with you? So I'm going to rewrite this now as 3 times log base b of n. Okay, multiplication is nothing more than what? Repeated addition. If I wanted to write this as an addition problem, what would it be? Log base b of m plus
log base b of n.
Yeah, exactly. It's the same. I have to have the same thing 3 times, right? That's what that means. Okay, now using the product property, what could I do? I'm going to go like this and expand this page down. How can I take these two and condense them? What would that become?
Log base b.
It'd be log base b of, I would take these and do what with them? Multiply them, so it'd be m squared plus log base b of m. Okay, then I'm going to do the same thing again. So what's going to happen? I'm going to get log base b of m to the 3rd power. Now what I want you to look at is, look at the exponent of m compared to the value of n. What are they? They're the same. And that will always be true. So the power property says, hey, if you take n, some constant times a logarithm, like this, you can rewrite it as log base b of m to the n. Okay? And again, you are allowed to go either direction you want. Either direction you want to. Okay? Now there, since you have a logarithm on both of them, we really don't call them maybe condensing and expanding as much. I would still say going here is condensing because I don't have anything other than a logarithm. Okay? But being able to go back and forth using the power property is going to be important as well. All right? Okay, so those are the 3 properties you need to know for logarithms. First 3, product property, quotient property, power property of logarithms. Anybody want to ask anything on those before we try looking at those a little bit? Okay? Yeah.
For the quotient property, n can be negative, right?
This?
Yeah.
Okay, so let me ask you this. On logarithms, is the base allowed to be negative? Is this value allowed to be negative? No. And do we remember why was that? Who remembers why when I have this, if I did this, why is b greater than 0 and why does m have to be greater than 0? Why is that? Who can explain it to me why? Yep.
I don't know if I can get super technical, but if b is always going to be greater than 0, no matter what value of n, it's always going to be greater.
Okay, so if this is true, if b is always positive, b to any power has to be positive. So that's why m is. M is a reflection of b. Why is it that b is? Because we said that logarithms are the inverses of what? Exponential. And we said in exponential, the base must be positive. Because if it's not positive, if I go y equals -3 to the x, there's the base that's negative. Guess what happens on that? The graph goes here, then here, then here, then here, and it goes doop, 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 doop. It goes back and forth, and it grows. It's not growth or decay. So by the definition of what an exponential function is, the base had to be positive. The same then follows true for the logarithms. It has to stay positive on that. Okay. Woo! All right. Anybody else? No? Okay. Well, let's try something here. There you go. Solve it. Solve it now. Okay? Solvey, solvey. See you, lady. One property of logarithms for this. What will this condense down to on the left-hand side? Maddie?
Log base 4 of x squared minus 6
Good. So you took these two things and you did what with them?
multiplied.
Multiplied it. And you did it in your head, and then I'm going to write it like this. And I'll put it in parentheses so I know it's the entire thing. Is that right?
Oh, I didn't put 6x, I just put 6.
Yeah, because it's this times this, which means you have to do what?
Well,
Distribute it
out.
through. Okay? And then that's going to equal 2. Now what do I do? Yeah, exponential form. What would this be in exponential form, Hamza?
4 squared equals x squared minus 6x.
Beautiful. Now I'm dealing with what kind of a form? What is this I'm dealing with now? What kind of an equation is this? Kind. X squared. Quadratic. It's quadratic. How do I solve this? Factor it. Quadratic formula. One of the two. But I have to get everything on one side instead of equal to
0.
0. So I'm going to do that. Here we go. I'm going to move this over there. What's it going to become? X squared minus 6x. When this goes over, what's going to happen? Minus 16 equals 0. Now, can it factor?
Yes.
Come on, that was nice.
Negative 4, no, negative 8 and 2.
Negative 8 and plus 2. Right? Okay. This is our goal, is to be able to do things like this. So our solutions are x equals 8 and x equals negative 2. Now somebody needs to talk to me right now. What?
You need to check those solutions because they don't always work out.
Correct. I need to check them. Now I want to go back to the original equation. I'm going to just get this stuff out of the way. I want you to look up here. When we just got done talking about this, it was kind of nice. We said that both b and m had to be greater than 0. I want to focus on m. M must be positive. This value has to be positive. Okay, so if I'm looking at this one, x has to be greater than 0. If I'm looking at this, x minus 6 has to be greater than 0. That means x has to be greater than what? Now I can look down here and I know what works and what doesn't. Which one does not work? The negative 2. It's out of here. Wah! Okay. The 8 works in both of them. Love it. Give x equals negative 2 the boot. It's extraneous. So that is what we're trying to do now. We're trying to be able to solve higher level equations with logarithms in them using properties of logarithms. Okay. So we had laws of exponents to help us solve those kinds. Now we have properties of logarithms to help us solve those types. Any questions on this problem? Okay, here we go. Try this one. This one really freaks people out for some reason. So everybody read it. Oh, we're doing great. This is about the exact same place I was last period at this time. Perfect. So find those two things down there. Find them. Calculate them. Give me. I want numerical answers for those. If you need one. If you need one. Oops. By the way, I can make him attack, Abby. He will attack if I tell him to.
What is happening?
You don't know what that is? It's like only a few of those left in the country. It's a bald meagle.
Meagle?
Yeah.
A mountain eagle?
Yes. It's a bald meagle. It's a relative of the bald squeagle.
A squeagle?
Yeah.
Oh, you gotta be kidding me.
No, I'm not.
Flying squirrel.
It's a squirrel eagle. Yeah. Bald squeagles. They exist and bald meagles do too. Almost extinct. I have one in captivity here. It's a bald meagle.
Is it in that bag?
It's right there. That's it. That's a bald meagle right there in front of you, and it will attack. It attacks. Oh man, you don't want to see it. If it takes off, I'd run. All right. So this bottom left one down here. There it is. I've given you one logarithm here, giving you two up here. Could I take this left-hand side and expand it? Oh, let's do that. Let's do a little expansion. If I expand this, what would I expand this into? Log base b of x plus,
log base b of y.
and I know that log base b of x is 1.209. Plus, I know log base b of y is 1.544. Which means I can get my final answer then of 2.753. Booyah. When we come back, we'll do the answer to the second one. We'll keep going. Now you can get the second one right if you want to. You got time. Same kind of problem. Don't. You almost knocked him off. Bald meagles. Taking it with me because I know you're a hunter. You will kill my bald meagle.
Yeah. You should do it.
0.665. I'll tell you, I don't know.
I got 0 or negative.
Oh, it's negative. Yeah, don't mind me, it's definitely negative. So, wait,
Gee, math stresses me out.
right?
Okay. Woo!
Are you educating everyone?
I am. They're all learning about bald eagles. Mr. Sullivan loves my bald eagle. He wants to borrow it.
How did you make it known?
Ah, that's good.
You should-
Bald eagle.
You should put it on the
I
live.
get it, it's a mixture of it.
What's that?
You put it on the live stream.
Oh,
What about
Okay. He's watching you. He doesn't like bad answers. Kind of makes him go a little berserk.
He's gonna have to get used to it.
So if you have a wrong, when I do this problem, if the next one's wrong, I would just do this. Let's like protect your neck. He's almost always goes for the neck for some reason. Sorry. All right. Here we go. So we got another problem here, and of course, we got to expand it. So it's going to be log base b of x minus log base b of y, which means it's going to be 1.209 minus 1.544, which means the final answer is 0.3. What? Huh?
I thought it was negative.
Oh, I like that answer. Wait, can it be a negative thing?
No.
No.
Yes, it can. It's not a logarithm anymore.
Oh,
These are values. Remember, these are what? These values here, okay? These values here are what? The exponents. Exponents can be positive and negative. So this could be a negative answer. And it is negative, you're right. Negative what? Negative point.
335.
3, 3, 5. Almost my root number.
665. What
Huh?
the heck?
I
Don't listen to me right
don't
now.
know how you got that. I'm sorry.
I
Okay,
don't either.
boom. There we go. All right. Woo! So, yeah, that's now where we expanded. We went the opposite direction. If we didn't condense, we expanded these. Here we go. Condense this into one logarithm, please. You're not solving anything. I just want it condensed into one logarithm, a single logarithm. A single logarithm. I need to see. Okay. Listen here. Give me a little. Doing that. I need to take attendance. I never did. Chapow. Yeah.
That 5 is a multiplier, right? Yeah.
On the right. Yeah, it is.
Is it being multiplied on the, oh, the right, yeah.
Yeah.
Just kidding.
It's okay. You're allowed to. I like kidding around. Ah, there we go. Yep, and yep. Everybody's here. Perfect. Good gravy. Love it. All right. Now, when I do this problem, okay, if you would, hold questions to the end, okay? I'll talk through it, but if you would hold your questions till the end, I'd like you to, if you would. So, when I look at this, I notice I'm adding logs, I'm subtracting logs, I've also got some logs being multiplied by constants. My first thought is I would like to go ahead and get rid of those numbers in front of all the logarithms. So I'm going to apply the power property of logarithms. That's where I'm going to start. So my first step is going to be, I'm going to do the power property of logarithms. And I'm just going to rewrite it. So this is going to become log base 2 of x to the 5th plus log base 2 of y here minus log base 2 of z to the 5th. All right? There we go. All I did, took the number in front, made it the exponent instead. Now I'm going to start condensing. I'm going to start condensing. I'm going to just work from left to right. That means I'm going to start with these two condensing them. Since it's adding two logarithms of the same base, this is going to be a product property now. So I could rewrite this as log base 2 of x to the 5th. So I've gone from this to here, from 3 logarithms to 2 logarithms. Now I have to do it again, and I'm going to condense these, and I'm subtracting 2 logarithms of the same base. So now I'm going to use the quotient property for logarithms. So here I'm going to get log base 2 of, it's the first one, x to the 5th y, divided by the second one, z to the 5th. Final answer is right there. Okay? So everyone looking at it. And now, does anybody have a question? No one has a question at all? And last period, I was so lucky because somebody actually asked exactly what I wanted them to ask without me even telling them to. Yes?
The exponents don't cancel out, do they?
The exponents don't.
Like 5 and 5.
No, because they're different bases. Because these two bases here are the different. So you can't cancel them out because those are not the same base. If that was an X and that was an X, then you could get rid of them, yeah. Okay. So nobody has a question? Hamza, do you have one? Well, if you were told to solve, you would go down to this, and then it'd be equal to, and then you go to exponential form, and you keep going.
Okay.
Now, you wouldn't be able to solve that because it has 3 unknowns.
How about how do you write it in exponential?
Say that again?
How would you write it in exponential if it's not?
It'd be 2 to some power equals that entire log. Because that's the rule, right? Here's log base p of x equals y. It'd be 2 to the whatever equals this entire thing. If I did this. That would be what? 2 to the question mark man equals x to the 5th y over. That's what would happen if you did that. Okay? But I didn't ask you to do that. I just wanted you to condense it. Now, the reason I wanted you to condense it, I actually have this problem written down twice. I have it twice. Once, there it is again. Because somebody in my other class read my mind. And they said, Mr. Snyder, I thought that was a -5. So I made this a -5. Ah! Whoa. All right, let's think about this thing. Are they the same if you do that? Is that okay to do that? We need to find out. So here's what I want to do. When you were in Algebra 1 class, you were probably taught that this is the same as that, correct? You were told that at some point in your career. Okay, so knowing that, here we go. I'm going to rewrite this as 5 log base 2 of x plus log base 2 of y plus -5 log base 2 of z. So instead of being -5, now it's plus a -5. We know those are equivalent. We know they are. You're along for the ride. You don't have to write all this down. Watch. Enjoy. It's like a trip. It's like a scenic trip. Okay, through the Rocky Mountains. Here we go. Power property. Log base 2 of x to the 5th plus log base 2 of y plus log base 2 of z to the -5th. Booyah. Condense. Log base 2 of x to the 5th y plus log base 2 of z to the -5th. Beautiful. I love it. Here we go. They're the same. So now I'm going to go log base 2 of x to the 5th times y times z to the -5th. Boom. Done. Now, in my infinite knowledge, and yours as well, we all go, hey, you know what? Z to the -5 is the same as 1 over z to the +5. So this is the same as log base 2 of x to the 5th y over z to the 5th.
Wow.
There it is. Same. Exact same. Your choice. Your choice on that problem. Okay? Love it. Okay. Let's get out of the split screen. Oh, I love me some good stuff like that. Love it, love it, love it, love it, love it. La 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 la. Okay, This is the other thing you need to know. Now, this is the one at the beginning of class I was kind of talking about. This is change of base formula. It's kind of a property as well, okay? This one, at one time, was very important to know. Very important. And I'll explain that to you a little bit, okay? It's called change of base formula. If you ever come up to me or you ask me a question and I go, Cobb, I'm telling you to use change of base formula, okay? So that's why I put Cobb. Or if you're doing a paper and if I write on there Cobb, that means change of base formula. So you're writing this down. I'm going to give you a second to write it down, and then we'll talk about what it's saying, because everyone's writing as of this point. Since you're doing that, I'm going to click this. That's good. Let's do this, and minimize that. Yeah, I can close that. Okay. All right, so here's what it says. First of all, A, B, C are positive numbers. So you're looking down here. Here's A, here's B, here's C. They're all positive numbers. We should automatically know they're positive numbers because they're logarithms. And we know that these have to be positive numbers. So again, we're stating the obvious for us. Those have to be positive numbers. Okay, great. Now look what else it said. With B not equal to 1 and C not equal to 1. Now those only occur together in the bottom. Why do you think this right here is even written down? You can tell me why B cannot equal 1 and why C cannot equal 1. No.
Because you
You can't
can't divide by 0.
divide by 0. Because if I make these both 1, that would be this. And 1 to what power is 1? One of the answers is 0. So that's why you can't do that. Okay? That's why they both cannot be 1. Now, having said that, we're going to move on. And now, what is this actually saying? Log base C of A is equal to log of any base B I want. It does not matter what it is. It's log base B of the inside number divided by log base B of the original base. So what I'm saying is this. This could be the common log of A over the common log of C. I'm using base 10 for both of them. Or I could use the natural log of A over the natural log of C. I'm using base E, the natural number for both of those. Now, why is this at all there for you? Okay, well, here's why. Remember earlier I gave you a problem, right? And it was like that one I gave you, I asked you to estimate. What was the very first one I asked you to estimate? Log base, what? Oh. Log base 8 of 68 was the first one I asked you to do. And I said, give me an estimate to this, right? I can tell you right now, using your calculator, you could just do the common log of 68 divided by the common log of 8 on your calculator to get an answer. Or you could do the natural log of 68 divided by the natural log of 8 on your calculator. And your calculators do common logs and natural logs. If you look at them again, whether you have this type here or some kind of graphing one like this, they have LOG buttons, common log buttons, and they have LN buttons, natural log buttons. So I'll show you. I'm gonna go ahead and use the graphing one because I have one of those ready to go. Okay. So here it is. This is my graphing calculator right here. Boom, it's beautiful. Okay. So I'm going to type in common log of 68 over here. Log 68. I have to close the parentheses there, by the way, right? Divided by the common log of 8. Boop, boop, enter. 2.029, a little over 2. Now watch, I'm going to do the exact same thing, but I'm going to use the ln, the natural log button. The natural log of 68. Whoop, divided by the natural log of 8. And again, I get the exact same answer. Now, that's why it's nice to know the change of base formula, because you can find the answer, a decimal approximation, by using common logs and natural logs on your computer, on your calculator, right? Well, a couple things. First of all, you now are going to be lucky. I told you that this is not as important as it used to be. That is because graphing calculators, not this type, not this one, graphing ones like this, you can put any base you want in and it will calculate it for you. So watch. If you're going to ever use a graphing calculator, you could do this. I'm going to use alpha. Now, alpha is the function button. If you notice up here in these keys, there's these yellow ones like this, F1, F2, F3, F4. If you hit alpha first and hit any of these, you get these little quick functions. Like these are fractions. Like this is a proper fraction. This is if you want to enter a mixed number in. The next one is if you want to go from a proper to a mixed number, a fraction to a mixed number, or if you want to go from fraction to decimal. That's what these do. What I want to do though, I'm going to get out of here. If I hit alpha and I hit the F2, look what the fifth one down is. Log base. I'm going to hit the number 5. And lo and behold, notice it says log and it's got a little cursor down here where the base goes. I could type in log base 8, arrow over of 68 and hit enter, and I'm going to get the same thing. Now, that's one reason that change of base is not as important as it used to be for you guys, because at one time, our calculators did not do that. They only did common logs and natural logs. So you had to know the change of base formula in order to convert, to get a decimal approximation. Okay? For those of you who don't have a graphing calculator and you use Desmos, have no fear. Here we go. All right, so here it is. I've got my, let's go ahead and clear this out. Oh, whoa, what is that? Okay, whoa, okay. So I could use change of base formula and just type it in. I could just go log, common log of what? 68, and then divide that by the common log of 8, and I'll get the answer. Okay, so it understands when I type log, it understands it's common log. I could do ln of 68 divided by ln of 8, and it understands that as well as the natural log. You also can go down here, okay? So if you open up the little keyboard down here, and you go over to the functions, way on the right, functions, hit it. And you have to go to miscellaneous, there's trig, there's statistics, there's distribution, there's miscellaneous. Down here under miscellaneous in the center, right here, is where you can make it any base you want. Click. Oh, let's get out of there. My bad. Let's do that again. Click, click. Well, let's do it again. Functions, click. There it is. Log base 8 of tab over 68. Get rid of that thing. And there's the answer. Again, that is one reason for you change of base is not as important as it used to be, because now you have technology that you can actually type in any base you want and it will do it for you. But there is a chance you will have to use the change of base formula when you're working with a logarithmic equation. So when we get to one like that, I will say to you, here is why you still need to understand change of base formula. Here's how you will use change of base formula other than just finding the value on something like this. Change of base formula could be used to solve an equation as well. And we will talk about that later, okay? So there you go. Change of base formula, again, not as important as it used to be, but it's still gonna show up a couple times in some equations, and we will talk about that, and then you'll see how you can use change of base formula to help you out, all right? Okay, great. Woo! Here's your homework. It's out of the book. I have pictures of those pages again on Google Classroom. So those pages are already loaded up to Google Classroom. They should be there, okay? And you can just open them up and you can do these problems. You probably won't have these finished today. That means we'll go ahead tomorrow at the beginning of class. I'll have the answers up there. We'll go over those. After we go over these tomorrow, we're going to be solving some equations and we're going to be looking at some word problems maybe and solving equations as well. If we have a quiz tomorrow, listen up. If we do, it will be like a very basic, do you understand exponents and logarithms and their relationship? It could be rewrite in logarithmic form. Rewrite this in exponential form. Give me an estimate of log base 3 of 15. Anything like that is fair game. It will not be anything where you have to expand, condense, like that. It would be very, very, very basic, like a 3 to 4 minute quiz tops if I give one tomorrow. Okay? Like I said, basics. Do you understand what a logarithm really is? Would be what would happen tomorrow. Okay. All right, there you go. Check that. Beautiful. Beautiful, beautiful, beautiful. Youssef, if you don't want to hang around anymore, you're more than welcome to leave. Okay?
Okay.
If you want to hang around, you can. That's fine.
All right.
Shoo-ba-doo-ba-doo. La 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 la.